That is what we have seen now. This helical antenna we have seen, how to create a helical antenna and other things we have seen, and how to now creating an array of antennas. So what is an antenna array? So antenna array is a collection of antennas spaced at equal distance. So when what a single antenna cannot achieve, array of antennas can provide a huge gain. They can provide a huge beam. So all these things are provided by array of antennas. So the default thing is I'm going to have a rectangular array. So first thing I'm creating a rectangular array of antennas. You see here you're having a 2 cross 2 dipole. Size is going to be 2, 2. How to see how the arrangements are there in my antenna array. See how the antennas are laid out. So it is 4 dipole. You have 4 antennas, and the antennas are positioned like this. Array of antenna, right? So antennas are equidistant from each other, and it is positioned like this. It's a two-dimensional 2 cross 2 rectangular antenna array, and each one is a dipole antenna. You can see 1, 2, 3, 4, 8. So each one is an dipole antenna. So totally 4 dipole antennas we have. So this is called as an array. How to be the structure of the antenna array? This is essentially the top view, the side view. So you have 4 dipoles standing tall, parallel to each other. You have 4 dipoles standing tall. This is going to be the side view, and this is my top view. When you view all the dipoles, they will be circular in nature. Okay. Now plot the radiation pattern. So whenever you have an array of antenna, the radiation pattern will be highly directional. So the directional, since your dipole antenna is going to be an omnidirectional antenna, you will have radiation everywhere. So you can see the radiation everywhere. It's almost an omnidirectional antenna. The radiation pattern is the spatial distribution. So you can see the antenna is highly directive. It is radiating in all the directions. You cannot say it's a directive antenna, it's radiating in all the directions. Plotting the azimuth and elevation angles. See, the frequency is 70 megahertz. 70 megahertz. See here, on the direction of each dipole, you will have a beam. So you will have 4 beams totally along the 4 dipoles. This is the beam of 1, 2, 3, and 4. So this is the. You can click here and see the peak of 2. You can click here and see the peak of each thing. Okay, this is going to be the azimuth. Now we'll draw the elevation. The elevation is going to be this is the elevation. Also almost looking like almost in all directions you're going to have the signal. Okay. The dipole antenna has the poor directivity because it is going to radiate on both sides. Now calculating the directivity of the antenna. The directivity is minus 40. Minus 40. So it is very poor, having the poor directivity. Now plotting the EH fields. Plotting the EH fields, electric and magnetic field. See the value. The electric field is very less and magnetic field is very high. Magnetic field is even more as 10 power minus 5. Because the current excited to the antenna is very, very low amplitude. It is order of milliamperes. So you will have a very, very feeble magnetic field H, but the electric field is relatively very strong. And get the electric and magnetic fields of the antenna. Plot the polarization.